Alright guys, in this video we're going to talk about angles of elevation and angles of depression. We're going to now be solving right triangle problems using angles of elevation and depression, but they're basically still the same thing that what we've been doing. It's just really word problems of what we've been doing. So an angle of elevation, right? Think about if we're elevating something, it's going up, right? So the angle of elevation is always going to be where you're looking from. So that angle of elevation is down here at the bottom of our triangle, okay? Please note that we will always be drawing the triangle in the same direction every single time. So the height will always be on the left side here, and then on the right there will be our angle. Okay, for our angle of depression. Now depression really means that you're looking down. So it's really this angle here at the top. But notice that our line of sight and the rock at the bottom create that Z that we talked about that is always there if we have parallel lines. So the angle of elevation is actually the same thing as the angle of depression, which again means we're going to be drawing these triangles the same way no matter what word they've given us, whether it says angle of elevation or angle of depression. We're going to draw it the same way every single time. Okay, so let's look at some of our examples now. The key here is that we need to highlight, underline, make sure we are pulling out key information from our statement, okay? Now, the first thing I'm going to do is always draw my picture. So I am going to draw my right triangle, and again, I draw my right triangles the same way every single time, and because I'm using a fancy board, I'm going to use the right triangle tool that they've given me. Cheat a little bit. Okay, and I'm going to have my right angle there. Again, we are drawing it this way every single time. Okay, the first thing in this statement is that we stand 40 feet from a tree. Okay, the angle of elevation, so the angle in this problem is 47 degrees. I'm actually going to change colors because it's a different piece of information. And then we want to know how tall is the tree. So that again is a different piece of information. Okay, sometimes I find that it really helps to draw out our picture. So I'm gonna draw a rough sketch. I am awful at drawing, so don't make fun of my tree. I'm doing my best. All right, so there's my tree, and then I'm standing 40 feet from the tree. Put some blonde hair on there since I'm blonde. So you know it's me, of course. All right. So there's my little rough sketch. Now it says that I am standing 40 feet from the tree. So here's me and here's the tree. So right along the bottom is where I'm going to put my 40 feet. Okay, we've dealt with the information in red. I'm going to switch to blue. It says the angle of elevation is 47 degrees from the top of the tree. Again, no matter if it says angle of elevation or depression, we're sticking it at the same spot every single time, and that is the angle at the bottom right-hand corner there, okay? And then, or the right-hand angle, how tall is the tree? So our X value is how tall the tree is, which is over on this side. Now that we have it labeled the way that we need to, now we're just going to go back to using our trig. We're going to solve for the missing side. So I'm going to label my triangle H between the right angle and our given angle. Remember, it's that side that's touching both of those angles. That gets the letter A. And across from the given angle gets the letter O. Okay, then I'm going to write SOHCAHTOA at the top of my paper because I do not want to forget it. It's not going away. Please make sure you have this written down. Okay, and I'm going to circle the information that I have. So I have information on X, and I have information on about 40. So those are O and A. So O and A is tangent. Right, now we're going to write our equation. Tangent of our angle is equal to O over A. O was X. A was 40. And I'm actually going to go back here and put the colors in to kind of help you out so you know where I got those things from. Okay, now I'm just going to go to Desmos and I'm going to plug it in. When we open up Desmos, the first thing you should do is go to your wrench and hit degrees. And now we're going to type in tangent, or we're going to use the keypad on the bottom to hit tangent of 47 equals X divided by 40. Okay, I don't see my line. I'm going to zoom out till I can find it. And we're going to round to the 10th place today. So we've got 42.89. The 9 rounds the 8 up. So 42.9. And because we're dealing with real life things, we're going to make sure we put the measurement as well, or the unit. So X is equal to 42.9 feet. Okay, let's try again. Again, I'm going to have my right triangle drawn first. That's the first thing I'm going to do as soon as I see this. Okay, we've got Miguel looking out from the crown of the Statue of Liberty, approximately 25 or 250 feet above ground. Okay, so I'm going to put my Statue of Liberty over here. Again, I am not an artist. And Miguel is standing in her crown. There he is. I know, she's beautiful. And then he sees a ship coming into the New York harbor and measures the angle of depression as 18 degrees. Okay, so let me put 250 feet over here. I'm going to put my 18 degrees. Again, the angle always goes in the bottom right hand angle. And we want to find the distance from Miguel to the ship. So again, Miguel is up here. The ship is down here. So from Miguel to the ship would be this side over here. It'd be our hypotenuse. So now we're going to label across from the right angle, we've got H. Between the right angle and our given angle is A. And across from our given angle is O. And then I'm going to circle the information that I have, which is H and O. And then our angle is here at the bottom. I'm going to write SOHCAHTOA on the top of my paper so I can decide which function I'm using. Okay, so we have got O and H, which is the sine function. So sine of our angle equals our O, which was 250, over our X, because that was our H value. And again, I'm just going to go to Desmos and I'm going to type that in. So function sine of 18 equals 250 divided by X. I'm going to have to zoom out because I don't see that on my graph yet. Oh, there it is. I can't click it. So I'm going to have to zoom in. And we're rounding to the 10th place, so we're going to have to zoom in quite a bit. Okay, I've zoomed in so that I can see where I'm rounding to. So notice that I am here. I'm between a 1 and a 2. The 1 doesn't round up to 0, so it's just 809 feet away. 809 feet. Okay, last example here. I'm going to draw my triangle. And then I'm going to mark my question. So I have got a 20-foot ladder that leans against a wall. Okay, so my ladder, it's not a very straight ladder apparently, is leaning against the wall. And then my, just 20 feet. So that the base of the ladder is 8 feet from the building. Okay, so that's another fact, 8 feet from the building. So base of the ladder, the building is over here, so this is 8 feet. And let me put my building in over here. I'm saying my building is made of bricks. All right, so my building's over here. My ladder here. We want to know what the angle the ladder makes with the ground. So that again is our angle of elevation, and that's where we're looking for is theta there. We don't use theta a lot, so let me switch that to X. So X is what we're missing. Now we're going to label across from the right angle. We've always got H. Okay, here's our angle and our right angle. So angles start with that A. So that's the A side, and then across from it is our O. And then I'm going to write SOHCAHTOA at the top of my paper. And we're going to circle the information that we do have. We have something on 20, and we have something here with the 8. So that's A and H. A and H is cosine. So we've got cosine of our angle, which is the piece we don't know, equals A, which is 8, over H, which is 20. Remember, when we're typing this in, we don't want to type this function in. We want to use our inverse function because it'll cancel out the cosine there. So we're going to say cosine inverse of 8 over 20. And that's going to equal our x. And because we're doing a degree, we want to round to the nearest degree. So let's go to Desmos. We're going to type cosine inverse of 8 divided by 20. We're going to get 66.4. So that's just 66 degrees. Again, each time you do this, make sure your calculator is in degrees. If you have any questions, please see me in class.